So welcome to another session of Everyday Mathematics. Here at Everyday Mathematics, we always say, we do enjoy solving the harder problems, but also we do see and appreciate the beauty in the simpler problems. Today's problem comes from the MIT 2024 Integration B Quarterfinals number 4, and problem number 3 is what we'll be focusing on today, which is the indefinite integral of sine x over 1 plus sine x times cosine x over 1 plus cosine x. So this is an interesting problem. Before I jump into trying to solve it, I'd like to thank our subscribers. Thank you so much for the support you can give us. For first-time visitors, what we do at Everyday Mathematics, we just go around and about and look for interesting problems, and we come back and we do share with you the solutions that we think befit these problems. For those of us who are coming back but haven't subscribed, we do really encourage you to subscribe to our channel. Your support would really go a long way in giving us the extra visibility that we do need to improve our channel or keep growing. So the first thing with this problem, I personally, what I would do is I like to express it in a way that could be integrated using the natural log approach. So if we look at the denominator, 1 plus sine x times 1 plus cosine x, that's the same as 1 plus sine x plus cosine x plus sine x cosine x. Therefore, the numerator sine x cosine x is the same as 1 plus sine x times 1 plus cosine x minus sine x minus cosine x minus 1. And using the identity sine squared x plus cosine squared x equals to 1, we can replace the 1 here with the sine x, cosine x, sine squared x plus cosine x. And therefore, if we do go ahead and plug whatever we have here in the numerator here, that will help us quite a bit. So let's go ahead and then plug that in the numerator. So the integral of sine x over 1 plus sine x times cosine x over 1 plus sine x, the same as the integral of 1 plus sine x times 1 plus cosine x minus sine x minus cosine x minus sine squared x minus cosine squared x, right? Over 1 plus sine x times 1 plus cosine x. So the first component here, obviously, we will cancel with the denominator. So essentially, this and I mean, let's try to separate things around. So that will cancel. So we have a 1 there minus sine x plus cosine x plus sine squared x plus cosine x over 1 plus sine x times 1 plus cosine x. Now we can collect like terms together, sine x and sine squared x. Those could be pulled together such that we can then go ahead and factorize, and then one of the item in the denominator can go away, and then same thing goes ahead to happen in the second part where we factorize the cosine squared x terms, right? So we've grouped sine x and sine squared x where we pull out sine x, so we have this and that canceling, and then for the cosine x times, that and that cancels out, right? So we are left with now 1 minus sine x over 1 plus cosine x minus cosine x over 1 plus sine x. This can easily be integrated. So for 1, that's the same as x plus sine x over 1 plus cosine x can be integrated to natural logarithm of 1 plus cosine x minus cosine x over 1 plus sine x is the same as natural logarithm of 1 plus sine x, and then plus the integration constant c. So this is the simpler approach that one could use, and it did require somebody to have that intuitive way of figuring out what the numerator required. But if you don't have that intuitive approach, the next method would be a good one. First of all, obviously, we can group these two log terms into one single log function, which is x plus natural logarithm of 1 plus cosine x over 1 plus sine x plus the integration constant c, right? So then there's a method too that probably would appeal to the less intuitive approach to it, and that is we could use the half angle approach. So sine x over 1 plus sine x times cosine x over 1 plus cosine x could be now expressed in the half angle formalism where sine x is the same as 2 sine x over 2 times cosine x over 2 times cosine x is the same as cosine squared x over 2 minus sine squared x over 2. And then obviously 1 plus sine x is 1 plus 2 sine x cosine sine x over 2 cosine x over 2. And then cosine 1 plus cosine x is the same as 1 plus cos squared x over 2 minus sine squared x over 2. Then we can say let u be equal to tan, let u be equal to tan x over 2, right? Such that du dx is the same as a half sec squared x over 2. And therefore, what that means is that we have 2, this is multiplying both sides by 2, 2 du over sec squared x over 2 is equals to dx when we multiply dx on both sides. And that means that now 2 du over tan squared x over 2 plus 1, since sec squared x over 2 is the same as tan squared x over 2 plus 1, means that now expressing this tan squared x in terms of u, the same as 2 du over u squared, the tan squared x same as u squared, plus 1. And so we can substitute dx with 2 du over u squared plus 1. And if you have a triangle and the base angle is x over 2, it means the hypotenuse, the opposite is u, and then the base is 1. Since a tangent of that base angle is the same as opposite over adjacent, and therefore the hypotenuse becomes square root of 1 plus u squared, obviously using the Pythagorean theorem. And therefore, since we know that our equation is this, then for where sine x over 2 is the same as opposite over hypotenuse, which is u over square root of 1 plus u squared. Cosine x the same as base over hypotenuse, which is 1 over square root of 1 plus u squared. The same thing here, cosine squared is 1 over 1 plus u squared, since we have this 1 over square root of 1 plus u squared squared. And then sine squared x the same as u over 1 square root of 1 plus u squared, all that squared, so we get u squared over 1 plus u squared. And so we do apply the same thing for 2 sine x over 2 and cosine x over 2. And then for cos squared x, the same term here, since it's here, we can take this same thing down here. And then for dx, we have 2 du over u squared plus 1. Okay, as we continue simplifying that, it means that when we multiply this to the square root of 1 plus u squared, it becomes 2u over 1 plus u squared. And then here, since the base is the same, so we have 1 plus u squared in the denominator, and then 1 minus u squared in the numerator. And then here again, obviously the same thing happens. So we have 2u over 1 plus u squared, and then plus 1 here, and then there's plus 1 minus, again here, 1 minus u squared over 1 plus u squared. So simplifying things further, pulling these two out, and then multiplying the denominator with this constant term here, 1. So we have 1 plus u squared plus 2u over 1 plus u squared, and the same thing here, 1 plus u squared plus 1 minus u squared over 1 plus u squared, right? So going on, this 1 plus u squared plus 2 is the same as 1 plus u squared. And then here, this term and this term goes away, so we have only 2. So the thing that we can see here is that this and this goes, this cancels with this cancels with this. And now we're left with u times 1 minus u squared over 1 plus u squared times 1 plus u squared. This 1 plus u squared comes here, right? Then we can now factorize 1 minus u squared, the same as 1 minus u times 1 plus u, so that 1 of the 1 plus u in the denominator cancels with that. And so the integration becomes 2 times the integral of u times 1 minus u over 1 plus u times 1 plus u squared. So we can now use, we can try now to simplify this fraction. Can decompose it a little bit, but first of all, we'd have to multiply u across, right? So the first thing I would do is I would say 1 minus u squared over 1 plus u times 1 plus u squared is equivalent to a constant over 1 plus u plus bu plus d over 1 plus u squared. Then I can multiply this denominator across so that u minus u squared is equals to a times 1 plus u squared plus b u plus d times 1 plus u. So multiplying things out, we find that a plus d plus b plus d times u plus a plus b times u squared. Since we don't have any constant here, then it means that a plus d is 0. And since we have a constant of 1 here, it means b plus d equals to 1. And then a plus b is equals to negative 1, since the constant behind the u squared is negative 1. So what this means is that since we have a plus d equals to 0, it means that a equals to negative d. And then since a is the same as negative d, we substitute negative a in place of d here. It means that b minus a is equals to 1. And therefore, so using this, negative a plus b equals to 1. And we know that a plus b equals to negative 1. And we add these two equations. We have a simultaneous equation here. This plus this means that the a cancels out, and we have 2b equals to 0, since 1 plus negative 1 is 0. That means that b is 0. And so we can go back and say, okay, since we know that b minus a equals to 1 and b equals to 0, it means negative a equals to 1, and therefore a is equals to negative 1. And therefore, since a equals to negative d, then it means that d is 1. Okay, so we know that a is negative 1, b is 0, and d is positive 1. So if our integral 2 times the integral of u minus u squared over 1 plus u times 1 minus u squared is equals to 2 times the integral of a plus a over 1 minus a plus u plus b of u plus d over 1 plus u squared. This means that the same as the integral of 2 times the integral of negative 1 over 1 plus u plus, since b is 0, we have 1 over u squared. This can easily be integrated, since this is just the same as negative 2 natural logarithm of 1 plus u. And then this, the integral of 1 plus 1 over 1 plus u squared, is the same as arctangent of u. So we have 2 times arctangent of u, and then obviously plus the integration constant. But since we know that u is the same as the tangent of x over 2, that's what we substituted u with, or we substituted the x with. And then it means that where we have u here, we have tangent x over 2, and then we have u here is the same as a tangent x over 2. So here, obviously, things are easy. That means that the arctangent of tangent of x over 2 is the same as x over 2. So we just have 2 here times in bracket x over 2. This 2 would cancel, so we have x. And then the next focus would just be now to focus on simplifying whatever is under the log sign. And so the log function. So we have tangent of x over 2 is the same as sine of x over 2 over cosine x over 2. And so what that means is that when we can simplify this further by saying this is the same as cosine of x over 2 plus sine x over 2 over cosine x over 2. And then these two can go up here using the rules of logarithms. That means that now we have a negative natural logarithm of cosine x over 2 plus sine x over 2 over cosine x over 2 squared plus x plus c, obviously c being the integration constant. And so when we square the numerator, we get cosine squared x over 2 plus sine squared x over 2 plus 2 sine x over, so the next cosine x over cosine squared x. So cosine squared x over 2 plus sine squared x over 2 is the same as 1. So we have 1 plus, and then 2 sine x over 2 plus cosine x over 2 is the same as sine x. Then we still have cosine squared x over 2 in the denominator. So cosine squared x over 2 is the same as a half cosine squared x over 2 plus a half cosine squared x over 2, right? And obviously we have x in integration constant c. That means that now we have now log, negative natural logarithm of 1 plus sine x over half cosine squared x over 2 plus a half cosine squared x over 2 is the same as 1 minus sine squared x over 2. Since we have the identity sine x squared over 2 plus cosine squared x over 2 equals to 1. So cosine squared x over 2 is the same as 1 sine squared x over 2. So substituting that in plus cosine squared x over 2, that means that now we have half cosine squared x over 2 minus half sine squared x over 2 plus a half. Now we can pull that constant half out. What that means that now we do have 1 over sine x over half cosine squared x over 2 minus sine x squared x over 2 plus 1. Now this cosine squared x over 2 minus sine squared x over 2 is the same as cosine x. So we can now write that this is the same as negative natural logarithm of 1 plus sine x over half cosine x plus 1. So using the laws of logarithm or rules of logarithm, we can pull this half out since the product of these two numbers is the same as the sum of the logs of the independent terms. But since it's in the denominator, we can now just put a negative. So we have minus natural logarithm of 1 plus sine x over cosine x plus 1 minus log half plus c plus x plus c. So this is a constant, and we can bunch it with this constant so that eventually now we do have minus log 1 plus sine x over cosine x plus 1 plus x plus c, because this is just a constant that can be bunched together with that constant. And so we can, by reversing now these items so that the negative sign goes away, so we have x plus natural logarithm of 1 plus cosine x over 1 plus sine x plus c as our answer. So this is obviously a much winded or solution to the problem, but it is all the same interesting, just showing you that however way you try to solve it, I think the answer should be the same. But yeah, it was an absolute pleasure solving this problem, and I hope you do enjoy following along. Until next time, bye-bye. And yeah, please, if you haven't subscribed, please subscribe to our channel. Just help us, give us that extra visibility. Thank you.